Okay, in a class library, the number of fiction and non-fiction books is in the ratio of 5:1. If we remove 4 fiction books and add 2 non-fiction books from the library, 1/5 of the books will be non-fiction books. How many books are there in the class library? Okay, so what we're going to do is we are going to record down before change after, because I have a ratio here in the before, and this fraction I can also translate it to a ratio in the end. Okay, hence it's quite convenient for me to record down before change after. Right, so let's go on to do that. So fiction to non-fiction. So F to NF, 5:1. We're going to show the change. So the change is that if I remove 4 fiction books, so remove means it's a decrease. So fiction minus 4. And I add 2 non-fiction books, so it's an increase, so plus 2. Now, in the end, 1/5 of the books will be non-fiction books. So when I say 1/5 of the books are non-fiction, we can understand that this one is the non-fiction. Okay, which is, I hope you're clear on this. 1/5 of the books are non-fiction. So obviously the 1 is non-fiction. Now the 5 here is referring to the total books, not the fiction books. Okay, if it's the fiction books, they would have phrased it like that. They would have said, there are, for example, in the end, there are 1/5 as many fiction books as non-fiction books. Okay, they will have phrased it like that. Then the 5 units will be the non-fiction book. But in this case, they didn't do this now. All right, so this one is out. All right, so 5 units is your total. So in this case, if I write fiction to non-fiction ratio, it will be 1:4 because 5 minus 1. Okay, that's how you get 4. Some of you might write non-fiction to total. If you recognize 5 as a total, you write NF to total. That's fine also. Okay, then that'll be 1:5. That's okay. All right. But I'm trying to be consistent with the before ratio. Hence, I followed the same title. Okay. Okay. Now moving on. Remember, once we have recorded down all our before, change after, and the ratios, we need to identify the common base. Okay. So common base, remember, we have 4 things to consider: fiction, non-fiction, total, difference. These are the 4 things. Okay. So let's look at it one by one. So for the fiction books, should the fiction remain the same throughout? Obviously not, because I have a loss of fiction books here. What about non-fiction books? Should it remain the same throughout? Of course not also, because non-fiction books, I add 2. There's a change of 2. It cannot be the same in the before and after. Okay. Now, what about the total? Total, will it remain the same throughout? Of course not, because here, -4 plus 2, it definitely would disrupt the total from the start to the end. What about the difference? Difference also cannot be the same because of, 1 is minus, 1 is plus. Can't be the same. Okay, so you see, nothing stays the same. All these 4 things, none of them stays the same. Okay, so what does that mean? That means there is no common base in this case. There is no common base, okay, between these 2 ratios. So if there is no common base, we are going to use this method called units and parts. So what does this mean? Okay, so units and parts means that you are treating these 2 ratios as 2 separate families. Normally when we do common base, right, we are uniting 2 or more ratios into one single family. Whatever value of 1 unit I have will apply to all the family members. However, for this one, because they do have a common base, they got to be treated as 2 different families. So with 2 different family names, we're going to call this one units, we're going to call this one parts. Okay, UUPP. So when I assign UUPP like that, that means the 1 unit value here will not necessarily be the same as the value of 1 part here. That means, for example, here 1 unit could be 10 books, whereas 1 part here could be 15 books, example. Okay, so we never know, but we know that for sure the 1 unit value and 1 part value usually will not be the same. Okay, so once I have this UUPP, we're going to form 2 different equations. Okay, so how do I form the 2 equations? So I'm just going to highlight. If you want, you can use your highlighter, 2 different color highlighters. I'm going to highlight one color for fiction. I'm going to use another color for the non-fiction. Okay, so now moving on. I'm going to form two different equations, one for the yellow ones, one for the green ones. So the yellow ones would be friction. So let's start with that first. So you look at from the before, change, and after. 5u minus 4 in the end will lead you to 4p. So 5u minus 4, you can put equal 4p. Okay, so yeah, this is what I just mentioned from two equations. See, 5u minus 4 equals to the 4p in the end. Now you're going to do the same for the non-fiction. So for the non-fiction, 1u plus 2 equals to 1 part in the end. Okay, so we have formed our two equations. Now the next thing, what do we do with these two equations? Okay, now in these two equations, you see I have two unknowns. Units is unknown, parts also unknown. I don't know what's the value of unit here. I also don't know what's the value of parts here, okay, which is very troublesome, right? Okay, so later your aim is to get rid of either the units or the parts in the two equations. Our later target will be this. Now, but before we do that, we need to proceed to make one of them the same. Either make units or make the parts the same. Okay, now you can make either one of them the same. However, in this case, we have an advice for you, which is to make the parts the same. To make parts the same also means to come up with your LCM, lowest common multiple between 4p and 1p. Now, why I suggest make parts the same in this case is because if you look at the left-hand side of the equal sign, your equal sign left-hand side here, there's so many things here. You have units, you have a minus 4, you have a plus 2, which is, it's a bit more complicated as compared to the right-hand side of the equal sign. Right-hand side of the equal sign, you have only parts, 4p and 1p. Okay, so if you make parts the same, it's a bit less complicated. All right, so let's do that. So we're going to make parts equal, which is 2 times 4 for the second equation. Now, you remember times 4, you cannot just times 4 for right-hand side. Everything times 4 together, hence put down the bracket like that. Okay, they are a team together. Now, once we have this, we're going to rewrite the two equations. First equation, no change, copy it down. Second equation, everything times 4, there'll be 4u plus 8 equals to 4p. There you go. Okay, so these are your two new equations that you're going to start working with. Now, the moment you have made both equations into 4 parts, notice that I can say something about this two. So since both equations are now equals to 4p, you see both are equals to 4p. What can you say about this left-hand side now? They are the same. This green part, okay, this green part and this orange part. Since the green part equals to 4p, orange part also equals to 4p. That means the green and orange can be equal to each other. They are the same value, right? Okay, so we are going to write that down. The green equals to the orange part. Can you see in my new equation here, what do you notice is missing now? Do you all realize the parts is now gone? This is how you manage to get rid of the parts. When you make parts the same, your aim, your target is that you will, not say target, when you make parts the same, eventually you will be able to get rid of the parts. If you make units the same, you will eventually be able to get rid of the units. So this is the whole idea. Okay, so can you see my new equation now, no more parts, which is a lot easier to work with, definitely. Okay, now moving on, what should I do? Okay, so from this equation, it's still a bit complicated, right? Still like, not so sure what to do. Okay, the reason is because there are 4 things now, 4 terms. 1, 2, 3, 4. You see, these are the 4 terms. 1, 2, 3, 4. When you have 4 terms like that, it's not so easy to work with, huh? So what you're going to do is you need to get rid of one of them. You can get rid of any one. Okay, so normally, right, I will compare units, you can get rid of the smaller units. Or you can look at whole number, minus 4 plus 8, then you get rid of the smaller number. Okay, which is really up to you which one you want to use. All right, now to get rid of one of the terms, we're going to use this thing called balancing equation. Okay, so balancing equation means that you treat this like a seesaw. The pivot point is here. Okay, now they are balanced because this equals this, so it's staying balanced. Okay, now I'm going to get rid of one of the terms. So let's say I choose to get rid of minus 4. Now you have to read this as minus 4. You cannot just read it as 4. You read it as 4, then it's like a plus 4 already. So to get rid of minus 4, I need to plus 4 to the left-hand side. Right? If it's plus 4 here, if it shows plus 4 here, you are minus 4, of course. So if it's a minus 4, you do the opposite. You have to plus 4 in order to get rid of it. Okay? Now, when I plus 4 on the left-hand side, my seesaw no longer stays balanced now. Okay? Because it would start to tilt, right? Right? Because I add 4 to the left-hand side, then it will suddenly start to tilt downwards. Okay? It will start to tilt this way. So if I want it to stay balanced, that means on the right-hand side, I need to take the same action as this. I also need to plus the same 4 to the right-hand side in order for the seesaws to go back to its balance. Okay, so now we're going to rewrite the equation. 5u minus 4 plus 4. So minus 4 plus 4 means the 4 cancel off already. So left-hand side only left with a 5 units. Right-hand side, 4u plus 8 plus 4. Now become a 4u plus 12. Can you see now I've reduced it to 3 terms? 1, 2, 3, 4 terms reduced to 3 terms. 1, 2, 3. Okay, so once I have 3 terms, can you see it's a lot easier to solve? Why I say that? Because 5u equals to this plus this, right? That means your 12 will be a value of 1 unit. Because 4u plus 1u must give you back 5u. There you go. You see, you have found out 1 unit is 12 books. So look at the question. They ask you how many books are there in the class library. Now, books means total books. Now, are they asking for before or after? Okay, the question didn't specify, right? But that's because the question, if you read back the start here, it's an if. If we remove or add whatever books we have there, it's an if, so that means this thing did not really happen. So the question then should be referring to the start original book. And your original total, as we can see, is 6 units. There will be 12 times 6. Okay, now if let's say this is not an if question, let's say they say that really, like, we remove 4 fiction books and add 2 non-fiction books, whatever it is, how many books are there in the class library in the end? Okay, so let's say I tweak the question, I change to how many books in the end. Now, if you look at in the end, right, there'll be 5 parts, not 5 units. So please do not go and take 12 times 5 because this 12 is for 1u. Remember I said before 1p and 1u may not have the same value. Most likely it will not be the same value. Okay, so how? So then never mind. If you have 1 unit is 12 already, what you can do is you can just find your 6 units at the start, and then you use this 6 units value, which is 72. You just move forward to find your 5 parts in it. That means 72 minus 4 plus 2. Then you calculate that out, and that final answer will be for the books in the end. So you don't really need the value of 1 part to go and find this out. You can just use the start total and just work forward to find in the end. All right.